Is my phone broken? No ring, no message. Or is it just that no one thought of me?
Loneliness is not simply an emotion that appears when people feel disconnected. It is a deep biological signal rooted in human evolution, designed to protect us from the dangers that once came with isolation. In early human environments, being separated from the group significantly increased the risk of injury, starvation, or attack. To prevent this, the brain developed mechanisms that make social separation feel painful. This discomfort was an evolutionary strategy, a reminder that survival depended on staying connected. In the modern world, physical survival no longer requires constant group presence, yet the brain still interprets prolonged isolation as a threat. During events like the COVID-19 lockdowns, when people were cut off from daily social routines and confined to their homes, this biological response became especially visible. When someone withdraws from social interaction for long periods, whether by choice or because circumstances force it, the brain begins to react as though something essential has been lost. The first changes appear in the midbrain. Research shows that as loneliness increases, the brain activates the same circuits it uses when the body is hungry. The brain treats social deprivation like a form of nutritional deficiency. As a result, cravings for food intensify, particularly cravings for sweetness. These cravings are not random. Sweet foods deliver rapid comfort and act as a temporary substitute for the emotional nourishment the brain is seeking. At the same time, the oxytocin system becomes highly engaged. Oxytocin is often described as a social bonding hormone. Its role in loneliness is more complex. In the early stages of isolation, the brain increases oxytocin-related activity in an attempt to sharpen a person's sensitivity to social cues. This is intended to help an individual reconnect more effectively once contact is available.
Hello?
But if loneliness continues, the system becomes dysregulated. Oxytocin production gradually declines, and the cells involved in its release lose stability. Instead of helping a person read emotions accurately, the system becomes overly reactive. The individual begins to interpret neutral expressions as negative, uncertain tones as hostile, and small signals as confirmation of rejection. This heightened sensitivity can make social interaction feel increasingly difficult, reinforcing avoidance and deepening isolation. During this period, another brain network becomes unusually active, the default mode network. This network is responsible for introspection, memory retrieval, and self-evaluation. When functioning properly, it helps individuals learn from past experiences and maintain a coherent sense of identity. Under prolonged loneliness, its activity expands beyond healthy levels. The mind begins to replay old memories with excessive intensity, often emphasizing moments of embarrassment, conflict, or perceived failure. These memories become distorted and emotionally charged. The individual may judge past events more harshly, assume others hold negative opinions of them, or convince themselves that social re-engagement will only lead to further rejection. Over time, these internal narratives reshape emotional responses, making the world appear more threatening and other people less trustworthy. As loneliness persists, the brain also undergoes metabolic changes related to chronic stress. Sustained activation of stress pathways increases levels of certain neurochemicals that interfere with the function of the prefrontal cortex, the region responsible for decision-making, impulse control, and long-term planning. When the prefrontal cortex becomes less active, behaviors begin to shift. Self-control weakens, making overeating, late-night wakefulness, and other impulsive behaviors more common. Sleep becomes irregular, which further disrupts emotional regulation and reinforces the cycle of isolation. Time perception also becomes distorted. Lonely individuals often report that days feel longer, decisions feel heavier, and future events feel more distant or uncertain. In addition to functional changes, structural changes in the brain can occur. One of the most significant involves BDNF, a neurotrophic factor that supports neuron growth, synaptic plasticity, and overall brain health. Under conditions of long-term isolation, BDNF levels drop sharply. A study published in 2019 examining individuals living in isolated Antarctic research stations found that after about 14 months of extreme isolation, BDNF concentrations decreased by nearly half, MRI scans revealed that the hippocampus, a region central to memory formation and emotional balance, shrank by 4 to 10%. The prefrontal cortex also showed measurable volume reduction. Meanwhile, regions within the limbic system, responsible for processing emotions, became more reactive. These changes together heighten emotional volatility, increase anxiety, and reduce resilience to stress. Loneliness affects not only the brain, but also the body. Chronic feelings of social isolation function as a prolonged stress state. Elevated stress hormones influence the cardiovascular system, increasing inflammation, raising blood pressure, and damaging blood vessels over time. Loneliness is strongly associated with higher rates of heart disease. It also correlates with unhealthy coping behaviors such as smoking, excessive drinking, and physical inactivity, which compound the risk. In older adults, the effects are even more pronounced. Age-related declines in hearing, vision, and smell can limit sensory engagement with the environment, making social interactions more difficult and reducing the sense of connection. Under these circumstances, loneliness becomes a significant predictor of cognitive decline and increases the likelihood of developing dementia. Despite the many consequences of loneliness, it is important to recognize that loneliness itself is a protective system, not a flaw. Like hunger signals the need for food and pain signals physical harm, loneliness signals a need for social connection. Short periods of solitude can be useful and restorative, helping individuals reflect, process emotions, and understand themselves. The danger arises when loneliness becomes a long-term state, and the brain's adaptive mechanisms begin to work against overall well-being. Understanding loneliness provides an opportunity to manage it effectively. Developing awareness of the emotional and biological processes at play can reduce their influence. Activities that strengthen self-identity and emotional stability, such as reading, writing, and physical exercise, help counteract the effects of isolation. These activities stimulate brain regions that support resilience and encourage healthier patterns of thought. They also provide a sense of agency, reinforcing the ability to guide one's own emotional state rather than being overwhelmed by it. Loneliness is a complex and deeply human experience. When acknowledged and understood, it becomes possible to navigate it without losing balance. By engaging the mind and body in purposeful ways, individuals can maintain stability even in periods of reduced social contact. The goal is not to eliminate loneliness, but to coexist with it in a way that preserves mental clarity, emotional health, and a grounded sense of self.